Sorry, I just got a recording message, that's fine. So we provide innovation test beds for SMEs which do not have, say, a big R&D capacity to try out certain technologies. We provide a brokerage portal to match the supply and demand in these embedded ICT technologies. And what is maybe the most attractive thing that we do is we provide funding up to 100,000 euros for technology transfer experiments via open calls. So let's zoom a little bit into the individual elements here. So what you see here, first of all, is our technology brokerage portal. So what I can do with this is, first of all, take a look at what are the nodes inside the TETRAMAX network. The idea is that we have 22 partners in this network, core partners, I should say, each of which is connected to a set of local partners. So altogether, we are 460 plus nodes right now. And the idea is, if somebody in Europe is now looking for a specific expertise, you can go to a search facility that we have and then say, for instance, I'm looking for a partner in Croatia that has expertise in computer vision. So you will find a partner to contact, and then you can just take it from there. Another feature of our brokerage portal is that we have postings for technology offers. So people that have an interesting technology that comes out of research can issue a brief description here so others can pick it up. And the same for the request or demand side. So companies which are in search for a certain expertise or technology can also create a post here to find somebody in Europe who provides that. So essentially, you can use this portal to do matchmaking, but we also have staff behind that that helps to get it done manually. Okay, so that's a brokerage portal. Then, as I said, we also do funding of technology transfer experiments, or TTX as we call them. And this happened via open calls. Unfortunately, all the open calls are closed now, but later we will see a few examples of the TTX that we actually funded in TETRAMAX. Just to give an idea, we had 3 types of TTX that we organized. One was actually inherited from a predecessor project called TETRACOM that was run in FP7, where we came up with this concept that a technology provider, which is normally university or another academic entity, creates an interesting piece of technology, say a software IP or a processor IP, which is then given to a technology receiver, which is supposed to be a European company, and then they would address a specialized market. And TETRAMAX would co-fund these experiments to bring the technology to market, just to boost up a little bit the overall technology transfer from academia to industry. In TETRAMAX, we also scaled this up to a more complex TTX scheme that we call value chain and is an interdisciplinary TTX, where several technology providers can team up to solve a slightly more complex problem. Then there will be multiple receivers to address specialized markets, but also wider markets than in this bilateral case. And the third type of TTX was this entrepreneurial TTX, which is a kind of pre-business planning exercise for startup teams which are willing to spin off a company from a university, but maybe they are not quite sure if they want to do it. So just to give you the number, so these TTX were funded with 25,000 euros. So as I said, we have essentially issued all our open calls. We are finalizing some of our TTX. So in total, we have 50 plus TTX in TETRAMAX, which were financially supported. So if you go to this tab here, you can actually see the list. So there's no secret about it. Who was funded, so which constellation of partners, so university and company, very often. And for most of these TTX, you can also find additional information, namely the the public report that they provided, plus a poster which describes the technology that was transferred at a glance. And for around 10 of these TTX, we also produced a short video clip. If I go back to the front page here, you can find them actually at the bottom. So these are kind of 1-minute teasers, which you can also find on YouTube, which explain the idea and the success story of the TTX in, easy to consume words. Okay, so some of our TTX actually ended up in real startup companies. So the TTX itself is not related to a startup company. It can just be a point solution for a certain company, but others resulted in scalability. So we have created, based on interviews with venture capital firms, this investor landing page here, where European startups can put a short message about who they are, what is their profile, and what type of funding they are looking for. If I just click on one of these here, you can see who are the people that are actually behind that, what is the desired investment, what is the market sector. And according to our VC sources, this is precisely the information that a VC firm would take a look at first glance to get an idea of whether this company is investment ready and whether it would meet their portfolio. Yeah, okay, so you can find more details here. As I said, last but not least, I would like to mention that there is also a good team behind this project. So I've been coordinating this project now for 4 years, and with a lot of help from Eva Haas. I think she's also here. So she's also she's a kind of CFO of this project and even the entire institute now. Dominic, our chief engineer, helped with many tasks here in TETRAMAX. And Katrine from Ghent University is taking care of the dissemination and communication. And I think she's also following this event here today. Then we have 22 partners from all across Europe, because our ambition was not to provide only the coverage of all technical topics in the embedded ICT domain, but also different types of expertise, like CENIT, for instance. I think I also saw Bernd Jansson here from CENIT. They are experts in networking and event organization, while you see many academic partners here as well, but we also have a handful of company partners here to make sure the SME views are also well represented. And on top of that, we also have compiled an interesting industry advisory board of people that we meet typically once per year to discuss the strategy of the entire project. Okay, I think that's what I wanted to say about TETRAMAX. Thank you.
Thanks very much, Rainer. I guess if anybody wanted to ask Rainer a question directly, you should speak up now. Otherwise, we'll move directly on to Kristina's presentation. But please go ahead, Kristina, if you'd like to share your screen.
Sure. Let me see. So
Kristina is running the BOWI project.
And I hope that you should be able to see only one screen currently.
It looks good now.
Okay, great. Welcome everybody, and thank you, Rainer, also for the introduction of TETRAMAX. As Rainer mentioned, I'm going to introduce another project of the Smart Anything Everywhere family and IFRMS family. It's the BOWI project. Similarly, it aims to support the adoption of new technologies by industry. And this is done also via open codes in BOWI. But before I go into this, let me start from the beginning. So the premise of BOWI is that digitization and innovation are important for the competitiveness as well as the achieving of greening goals in Europe. Unfortunately, there is still discrepancies between member states and differences in the adoption of digital and innovative technologies. And therefore, BOWI, which stands for Boosting Digital Innovation in Europe, aims to address this uneven performance between member states in the research and innovation by actually supporting collaboration between different regions and networks. And our main objectives are to support the collaboration between digital innovation hubs across Europe, because we think that these digital innovation hubs can act as regional stakeholders that can open up the region, and they can support both industry but also other stakeholders to meet in Europe and to collaborate. So by supporting this collaboration, we are aiming to increase the digital innovation hub capacities, and through that support SMEs with the digital technologies which could be, to be honest, quite broad in I4MS and smart anything everywhere it goes, from artificial intelligence to embedded systems to really flexible electronics, etc. And by this increased capacity, we're strengthening the regional economy and the competitiveness of European companies. As I mentioned, we see the digital innovation hubs as a key connection between the two regions. A key objective of BOWI, therefore, is to create a digital innovation hub widening network. And these digital innovation hubs between two regions can create a corridor of sorts in which a structural exchange of information, exchange of RDI and I results could take place. And then they can also connect to the regional ecosystem, to the local SMEs, to the local policy environment, to the local RTOs and universities to strengthen that collaboration. So why do we think that the interregional collaboration is so important? It's because we think that this is a way to support industry across Europe and to address an even adoption of innovations and digital technologies. So the collaboration for us provides an access to leading edge technologies and expertise across Europe. It can support new business opportunities, access to markets, it can provide good practices, etc., etc. Interestingly, it also is something that is supported by policymakers because it increases the impact of public funding. So how do we do this in BOWI? In BOWI, we do aim to create these collaborations between digital innovation hubs in two regions by also supporting SME experiments and forging these structural collaborations. So how it usually works is that two digital innovation hubs collaborate to help an SME to develop a new technology in a technology transfer experiment. This is supported with some funding, and via this support, the digital innovation hubs also force collaboration corridors that improve the digital innovation hub sustainability and also create networks that could further be leveraged on in the future. We are going to see from actually two of the experiments that have already run in BOWI. One is the Rofin 3D, and Mircea is going to introduce this in a bit, and the other one is the Semantic Intelligence that is going to be presented by Dimitry. So one of them, Rofin, is in actually Romania, and Semantic Intelligence is in Latvia. So we're going to hear more about their experiment in a bit. But what are the experiments in a nutshell? The experiments are developing digital solutions, and they're transforming technologies into actual implementation. So we're looking into TRLs 6, 7, 8. Until now, we have had 24 SMEs experimenting in 6 regions in Europe, and the second open call for technology transfer experiments for SMEs is coming up in the next months. So please stay tuned. And what is it for the SMEs? The SMEs receive some funding, European funding for the experiment. They also receive technical and business support from the involved digital innovation hubs and the core partners in BOWI. They also could receive access to specific expertise and facilities from the two digital innovation hubs. And their project is about 10-month duration, which provides them with an opportunity to, in a comparatively short amount of time, develop their ideas. And we think that these SMEs experiments and the collaboration between the digital innovation hubs actually brings benefits for all. We see benefits for the digital innovation hubs, we see benefits for the SMEs, we also see benefits for local and European governments. And these benefits could be summarized in access to European markets, economies of scale, access to state-of-the-art technology, expertise, and access to the networks. So just to tease you up a little bit, new open call for SMEs will open up soon. How can you find this and stay tuned for it? You can go to the BOWI-network.eu website. And there you're going to see that the second call for technology transfer experiments will be open soon. And to stay tuned, please join the BOWI community so that you can also read about the current experiments, some news about the collaborations, but also find when the open calls open. Are there any questions?
I wonder, Kristina, how long the BOWI project is running for?
The BOWI project is 40 months, if I'm not mistaken, and it started in 2021. So that means, 2020. I think that means July 2023 that we're finishing. Yes, I think so. Sorry, I have to make the math very quickly.
No, I
don't know the
understand.
deadline by heart.
The 48, the whatever plus. And will you be opening calls all along for the next couple of months for people to join on?
So as I mentioned, the first round of open calls for SMEs actually is closed. The 24 SMEs are almost finalizing their experiments. We have now expanded the BOWI network with new proto hubs and new mature hubs joining our network, and the new open call for SME technology transfers is expected by the end of the year.
Okay, thank you very much. If there are no other questions, we might pass on to the presentation from the BOWI project. And that will be János Lazanyi, who is the CEO of PCB Design. János, please feel free to share your screen. Thanks, Kristina.
Thank you.
Hello, everyone. Hope you see my screen. Tim, can you confirm?
It looks good to me.
Okay, so I'm János Lazanyi, the CEO of PCB Design, and I would like to present to you a technology transfer between our company and an Italian SME called NplusT. So really quickly, I would like to introduce the two partners. Of course, I start with ourselves. So we are a professional design center located in Budapest in Hungary. And what we are doing is complex electronics design. And we have more than 40 engineers, 70 customers all over Europe, and we make more than 150 different designs per year. So our key expertise is really printed circuit board design with high-speed interfaces and complex circuitry. And the HS car project that I'm presenting at the moment is actually a technology transfer between us and NplusT. And NplusT is an SMI located in central Italy, founded in 2002. And actually our partner is on the call right now, so hopefully he's confirming what I'm saying. And he's working in a semiconductor industry and making test equipments and characterization tools for a semiconductor industry. And also the third partner, which is a little bit invisible in this cooperation, is actually the BMIT TETRAMAX Competence Center, who was actually it's a center, but two most important people there is Béla Fehér and Peter Santo, who were just actually joining us together to make this happen. And now I will talk a bit more about the technology transfer that we did. So let me put up a slide first that what are the, hopefully I can hide this away, or if not, then it remains. So actually the background of this technology transfer, that everybody's aware of that of course SSD technology is actually moving into our everyday life. And the SSDs are based on NAND Flash technology. And this NAND utilization is actually is rocketing. And but unfortunately, the chips behind the NAND chips are not perfect at all. So actually, there is a lot of technology behind, which is hidden from the normal users to correct the errors on the chip itself. So actually, if you write a file to a non-disk, maybe it's not written perfectly, and especially it's not read correctly, and there is a significant effort to run background error correction algorithms to get back your data. And of course, as the capacity of the disks are increasing, the effort that is required is increasing as well. So unfortunately, these are not reliable products at all. So of course, there is a need for characterizing these devices. And actually, NplusT is really focusing on this. And they already had a previous product, which is characterizing the performance of NAND chips. But the device that we have been developing together actually is it's much faster, let's say, in this way, and it's involving high-speed design techniques that is required to run these interfaces, for example, at 1.2, 1.6 giga transfer per second. So actually, they were turning to us, and together we have developed the new version of this device. So what we bring into the system is actually the knowledge of the PCB design, and of course, they were responsible for the FPGA development and of course the application itself. So as you see also on this slide, in 2006, the transfer speed of these NAND devices were 66 mega transfer per second, and nowadays it's 1.6 giga transfer per second. So let's say within 10 years, the speed has been increased significantly. And not only the NAND devices, but of course the test systems should catch up with these speed improvements. The biggest headache is, of course, as this is a really high-speed device, the signal integrity problem is coming up. So we had to perform simulations, including the sockets, the devices, and the PCB itself. So actually, the technology transfer itself is the end result of this technology transfer is a new product called NanoCycler. And actually, Tamás is visiting Hungary tomorrow, because after this technology transfer, it really became a real product. And we are manufacturing the first 200 pieces of this actually in Hungary. And the engineering team is coming over tomorrow to test and see the performance of the first real units. You can see a picture on the middle somewhere. So it's a quite a complex PCB with an FPGA add-on board, and there's another add-on board on the bottom. What it does, actually, I would say it's quite easy to explain. On the top left or top right corner, you see a socket where you can put a NAND BGA device. And actually, based on this FPGA, we are running at full speed, at native speed. So we are reading and writing the cells of the NAND Flash chip. And also we are controlling the power supply and measuring the current consumption. And based on this, with the proprietary knowledge of NplusT, they can analyze the lifetime of the cell. They can predict the error rate of the device. And moreover than this, this is also in a temperature controlled environment. So actually everybody might know that the NAND devices are really dependent on the ambient temperature. So we can control the temperature of the chips as well. It's a small compact PCB, and on the top left picture, you see a full, let's say, rack of these devices. Each and every row has 6 of these small PCBs. They are interconnected together with a gigabit Ethernet interface, or if faster speed is required, even a PCI Express link is available. And in this case, you can run multiple tests, multiple devices in parallel, and you can characterize the performance of the NAND chips. So actually, this is the technology transfer we achieved. We help with them with the special high-speed PCB that you see on the bottom right corner. It's a quite dense PCB with impedance control, length matching, and all these kind of fancy technologies. And based on this, they could improve their product. They could have a much faster speed and develop a new product based on this technology transfer. So I think actually that was my presentation. It was quite hopefully in time and dense. If you have any question, I'm really happy to answer to that.
Okay. Thanks very much, János. And sorry, you're in the TETRAMAX project. Of course, I mixed up my paintbrushes. If anybody wants to ask a question, please share your video and ask directly.
Let me add something. I hope I am not muted. Okay, so I think that a good example, what is the really good spending of European money, because I don't remember, the transfer was around 40,000 euros. And we are now building a new system, which is, we are selling to for about $1 million. So it's really, I think this is a good return of investment for us, but of course also we appreciate a lot the help of the European Union, which was an enabler maybe in this case. The second is that the other good thing that we started this cooperation with PCB Design with this project, but it did not finish at the end of this technology transfer. So these guys are helping us also for this new production, because we needed to make some design changes, because you know the problem how to source components today. So we had to modify something on our tools. But also we launched other projects with PCB Design, and we are co-developing new products as well. And the third point, I would like to make a special thanks to Béla Fehér, who was the matchmaker, and unfortunately he's not with us anymore. That were my comments.
Thank you, Tamás.
Yes, thanks, Tamás. I wonder, János, I was curious when you talked about the simulations of high-speed signals. I'm a bit more into software. I wonder if you would say a few words about how you do that.
Yeah, so actually there is a specific tool called EBC-AMI simulation tools, and actually there are only 3 companies in the world who is offering a simulation tool. And the good thing is that it's not like a full wave EMI field solver, so it's not like an antenna simulation, because it would take forever for such a big amount of signals. But actually there is a simplified model of digital circuitries on the output and the input buffers. And these specific tools are allowing us just to really concentrate it, simulate the impedance mismatches and the S-parameter models of the different connectors. And based on that, within seconds, you can find out how the waveforms would look like on an oscilloscope, even running at like 1.6 gigatransfer per second. So it's a dedicated tool. It's called EBC-AMI simulation. And it's really high performance. You can run like a DDR memory, which contains hundreds of signals parallel. So it's a specific tool.
Okay, nice. Thanks very much. Did anybody else want to ask a question before we move on? No? Okay. Well, thanks again, János and Tamás. And so the next speaker will be Marc Bendahan. And hopefully this time, Marc, you are definitely in the BOWI project, I think. I know another TETRAMAX. It's not my day today. Please go ahead, Marc, when you want to start your presentation. I can see your PowerPoint.
You see the PowerPoint? No?
Yes, but not in the shared mode yet, just in the with the
okay.
toolbar and everything.
I'm going to share.
Okay, and you've got TETRAMAX clearly there. Great.
Okay, it's okay for you?
Perfect.
Okay, so hello, I'm going to talk today about the MEATRACK project, which consists on the development of a miniature gas sensor for real-time tracking of meat freshness in refrigerators. The aim, of course, is to reduce food wastage and health risk for consumers. So the consortium of this project is composed of 4 partners. 3 industrial partners, which is Envision, Nanos, and Sensing and Control. And the 4th, which is EM2NP laboratory from Aix-Marseille University, which is an academic partner. So the objective of the MEATRACK project, as we just say, is the increase of the smartness of refrigerators. How? Of course, by developing first and testing miniature gas microsensors. Why? As we say, to track real-time freshness of meat. And which what tools? So using patenting gas sensing technology from the laboratory, but combined with artificial intelligence tools of Envision, the first society, then IoT software platform of Sensing and Control Society, and finally With Nano's partners, we worked on the development of the electronic and the soft for the sensor prototypes. So the project is organized in 3 steps. The first step is the development of the gas sensor prototype and the lab experiments. The second one is the development of the artificial intelligence algorithms for detecting the meat freshness. And the third step is the integration of the gas sensor data and, of course, the IA algorithms into IoT platforms. So to do that, I'm going to introduce the work of each partner. First, Nano's Society, which is a startup, in this project realized the gas sensor, which is based on MOX technology, to measure the gases emitted by the meat in the refrigerator. When you are a meat, you can have bacteria, and if you have bacteria, you can have, as we say, BOC, which is gases. Okay. Nanos also developed the Bourke prototype, which you can see here, including a pressure sensor, a temperature sensor, and humidity sensor, and of course the gas sensors to measure the VOC emitted by the meat. The gas sensor is very small. You can see here 2 millimeters by 2, with a sensitive area of 200 micrometers by 200 micrometers. In each die, we have 4 MOX sensors and 2 sensors with 2 different sensitive layers to allow to have a database consistent. Then we also develop the software to drive the application and the acquisitions of the response under the measurements. Just to understand what is a MOX sensor, it's a substrate with an heater, micro heater, electrodes for measuring, and a sensitive film which reacts with the vapor, for example, VOC. When you have an interaction between gas and layer, in addition with thermal energy supply, we have transfer charges between gas and layer, and then we have a variation of resistance, so a variation of current. So the second step, of course, is the development of the bench setup in the laboratory. We can see here 3 boxes I'm going to describe, and the sensor realized by Nano's startup. So what we do, we have 3 boxes, 1 empty box for reference, and 2 boxes with 100, for example, 100 grams of meat. But this one is only to have a reference. What is a reference? For example, here we can see the baseline, so the response of the sensor in current during approximately 7 days. You can see there is a perfect baseline, so the sensor don't see anything. But if we analyze the 2 other boxes, we have a behavior which is completely different. During the first 3 days, we don't notice any changement in the response. So we attribute this with fresh meat. During 2 days, we have documentation of a rise of the current in the 4 sensors. The 4 sensors are different. So we have 4 different responses. And then after these 2 days, during 3 days approximately, we have a stagnation of the current with a high value. So when we open the boxes here, we can see that the meat is spoiled. So we have 3 status. We can determine 3 status with this sensor: fresh meat, acceptable meat, or spoiled meat. So after that, what we do? After that, of course, we work with Envision, and the role of Envision is to develop algorithms to identify 3 meat status. So we want to identify fresh meat, medium, and spoiled. For this, We use several variables which can be extracted for the gas sensor times to carry out descriptive data analysis. Namely here, PCA. PCA is principal component analysis, which allowed to understand the features correlation and which allows to visualize the existence of the 3-meet status. We also use classical models like discriminant factor analysis, which we trained and to validate also the selected variables and to test the new measurements. We can see here very clearly 3 status. So here it is spoiled, here it is medium, and here it is fresh. With these algorithms, then Sensing and Control Enterprise integrate the gas sensors data into an IoT platform. So it consists of the development of a cloud-based web platform adapted to present and manage data for the MEATRACK solution, which enables three things. First, real-time monitoring of all the data with a frequency of approximately 10 minutes. Also, analyze of the gas sensors to determine if the meat is fresh or not fresh. And also, we can visualize the historical of the compartment of the meat. Here we can see an example of real gas sensor retrieved when the data arrived at the web. And here it is the final MEATRACK solution. We can see the real-time data analysis and the notification of meat quality. For example, here Wednesday, we see that at 12:18 a.m., the meat status changed from medium to bad. And this is the interface used by the end users. So in conclusion, this project will be very interesting because there is a combination of different technical expertise of each partners. We have partners from gas sensor technology, we have a lab experimentation infrastructure, and artificial intelligence model, and also an IoT platform. And this combination of was the key of the successful of this project. For finish, I can present here all the people who participated at this project, and we are very thankful to TETRAMAX for this opportunity to be work on a very interesting collaboration project. Thank you for everybody.
Thank you, Marc. I would like to have had your sensor when I was a student. I think it would have saved me from some problems I had. I wonder if you could say a little bit more about the gas detection. So these kind of sensors that you have, are they keyed in to this one particular gas that I forget you mentioned it early on?
What this kind of sensor are not selective. Okay, they detect family of gases. But for example, gases reduction gases has a VOC, but also they can detect oxidizing gases, but not in the same way. For example, if you have an reduced gas, for example, VOC, you have a diminution of the resistance. Okay, if you have an oxidizing gas, you have augmentation of the resistance. Okay, because the gas trap, for example, an electron from the sensitive layer, or give an electron to the sensitive layer. So you have a variation of resistance, sort of variation of current. And then it is very interesting to have the tools of artificial intelligence to have a selective sensor, because the material is not very selective. It's very, very sensitive. We can detect PPBs from PPMs, but it's not a selective material. So it is interesting to combine this technology with AI tools.
Yes, I see. And I imagine you're running those AI algorithms off chip, they run in the cloud.
Yes, if you want, I don't talk about this, but this is very important. All the sensors are heated to optimize the chemical reaction, but also to dissolve gases. Okay, if you don't dissolve gases, you don't have a reversible response. So this one is very important.
Does that mean that your sensor will wear out over time? Will you have to replace them regularly?
No, these sensors are very stable. Okay, we can work with these sensors during several years. We can have a little derive of the baseline, but we can correct this.
Oh, I see. There's a question from Rajesh. Ketia, would you like to ask it directly, Rajesh, or I can ask it for you?
Yeah, I can ask directly. Thanks. So basically, will this technique also work for other perishable items like fruits and vegetables, or there would be difficulty in managing it for those items?
I don't hear you very well. It is a.
Oh, there's a question. Will it work for fruit and vegetables, Marc, your sensor?
Our sensors are able to detect vapors and gas. So all families, we can change the sensitive layer. For example, if we want to detect another thing, here we work with meat, but in our laboratory, we work also with alcohols. We work with pollution gases. We work with toxic gases. All molecules that we can have in vapor or gases are detectable. So if you are vegetables, we need to know what is the vapor degaged by the vegetables, and it is possible to try. It's a very open sensor.
Okay, thank you.
Okay, thanks very much, Marc. And I guess if anybody we'll move along, but if you have more questions or you want to talk with the presenters, they might be around at the end of the session in Zoom and maybe in GatherTown. You can maybe signal that on the private chat with the presenters if you want to meet afterward. Okay, the next speaker will be Dimitry Deviatkin from Semantic Intelligence, the CIO of Semantic Intelligence, from BOWI this time. Please take it away, Dimitry. We can't hear you, but we can see your slides.
Thank you, Timothy, and thank you everybody for attention. Our company focuses on developing AI automatic solutions for automatic text processing in biochemistry and life sciences. And thanks to BOWI project, we have launched and successfully done the project related to data curation. First of all, let me show you a short motivation slide. All research and development and academia organization, they generate a lot of texts related to their technologies and methods. And now we know there are more than 100 million full text patents, a lot of journals, and our type of data. And the significant share of the data belongs to biochemical field. And if one wants to build a kind of search engine, search system to help researchers to do search in these biochemical data, one needs to extract complex entities and relationships on that data and put it on the some structured database. The pipeline for that looks like this. At the input, we have different type of biochemical texts, like can be research papers, patents, clinical trials, but also there can be additional types of documents like research grants and reports. Then those raw text, they go through semi-automatic extraction. That means that people uses some automatic or manual tools to extract these main complex entities and relationships from the text. These entities can be proteins, genes, chemicals, virus-like particles and bacteria and other stuff. And they also have quite a complex relationship between them. But as far as curation, as far as extraction tools, they are not very perfect. The following step would be human curating of that extracted data. So we have a lot of human annotators and data curators who process those raw texts, extract information, curate that information, and put it inside some knowledge base. And because this process is really manual, the final cost of the data is very high. So that decrease possibilities for small companies and startups to use the data and perform their searches in biochemical field and life sciences, and therefore that reduces progress in the market. Well, what we propose, first of all, let's consider recent advances in technologies and basic science related to information extraction. Happily, recently Google has presented their deep neural network with a transformer architecture called BERT. This neural network achieves a very good accuracy in various fields and also in biochemical field. There is a special neural network, special version of BERT trained on PubMed literature called by BERT. And this type of neural network, it shows very good accuracy comparing to state-of-the-art methods. But unfortunately, that's the only good point. This neural network, it has quite low speed and very high memory consumption. Besides, use GPUs intensively, so one needs to buy expensive GPU clusters to run their applications. Besides, we can't anyway use this data directly without human annotation and curation, because the accuracy is far from 100%. You can see on the middle of the slide, for example, for chemical protein relationship extraction, we still have a bit above 75% accuracy. That means that a lot of portion of data should be created manually. To overcome those drawbacks and to make this technology really applicable for our industrial solution, we use 3 steps. First of all, we utilize noise detection algorithms. There are a lot of noise detection algorithms, and some of them are applicable for BERT neural networks. Our colleagues from German DFKI Institute, for example, developed one of them. So we used one of them and make the network not only to predict labels of the entities and relationship, but also to evaluate degree of confidence of the predictions. So we can then human annotator examine results of our extractions of our system. It can quickly navigate between noisy parts of the extraction. Besides, we applied techniques called quantization to make the BERT network smaller. These techniques consist in removing, exchanging some intermediate layers of the network and replacing them with networks with integer numbers instead of floating point numbers. That leads to reducing memory consumption and faster performance, and eventually that leads to ability to run our solution on CPU instead of GPU, and on having a good performance. Besides, to reduce costs of running our solution, we combine three additional technology, actually two additional technologies. First of all, Kubernetes, which helps us to upscale or downscale number of working nodes of our system. So if load of the system is low, we can reduce number of virtual servers and reduce costs of system running. Or if system load is high, we increase number of virtual servers and therefore provide users with high performance text processing. Small remarks regarding our results in the BOWI projects. First of all, when we applied this noise detection technique, after that we have an extensive validation and revealed that this validation can split the data into two parts. The first part contains very high accuracy level, and what is important, this is the greatest part. And the smaller part, it has lower accuracy, but as far as this part is just 10% of all text, it can be quickly processed by a human annotator. Second of all, we evaluated our quantization and revealed that our improvements help the system to achieve 3 times speed up. Eventually, we built a software module which can be embedded into text processing pipelines. So this module has program interfaces, APIs, which can digest raw text, perform automatic extraction of all information. Then it performs noise detection, and then it goes to human curators who can fastly consider noise examples and curate them. Therefore, we achieve better performance and reduce number of manual labor when a human do curation job. And secondly, we reduce cost of the databases. Eventually, for now, we have negotiations with 2 data providers who are validating our approach and considering the ability how to embed it into their own data processing pipelines. Besides, we are offering that module in 2 forms. First of all, like a software module, as I said in the previous slide, as a software module with program interface, but also we offer this as online service. So smaller data providers and companies can connect that service and curate their own data in biochemistry field. Besides, we are launching our own, based on that technology, we are launching our own IP intelligence solution, which can perform text and structural search in biochemistry field, and our technology is the core of that solution. So we are happy to collaborate with any company and data providers who wants to optimize their data processing pipelines, or who wants to enter the biochemical market.
Hello, Dimitry. Oh, I think, Dimitry, we can't hear you anymore. I had the feeling you were near the end of your slides. Okay, well, I think we've lost, you're still there, Dimitry. Okay, thank you for the presentation. Maybe we'll move along for the last talker, and anybody with any questions could ask them after the last talker. I think if you can stick around, Dimitry, that would be good. So the last speaker in this session will be Mircea Hotoleanu, who is the CEO of Rofinntech 3D. Please go ahead, Mircea, sharing your slides.
Yes, thank you, Timothy, and thank you, Kristina, for inviting me to this session. I hope you can see the slides, and I will put them on full screen. Good. So Rofinntech 3D, it's a Romanian company established in Cluj-Napoca in 2019, and the idea behind this company is to employ mathematical algorithms in general and artificial intelligence algorithms in special for various software applications that can be used as a vehicle to move the mathematics into practical applications. So we have touched a couple of domains. The main technology, as I will explain a little bit later, is the inference of the space. And then using this technology, we developed the project that I will talk about later, virtual staging with artificial intelligence. This project is basically the core of our activity within the BOWI project. Then separately, we also have initiated some projects on medical imagistics, and also we have a very long time experience in technology for laser modeling and simulation. So as I mentioned, the main technology of our company is the inference of the 3D space from a very simple 2D image. So starting from a picture of an empty room, we can actually detect the dimensions of the room and also the position and orientation of the camera that took that picture. So this technology is based on artificial intelligence. Actually, there are a couple of deep learning models. But not only, we also use whatever mathematical algorithms are needed. We are not focusing only in AI, but also in other kind of algorithms. Using this core technology, we employ it into a project where we basically offer the users the possibility to place furniture inside this room. This is possible because we know all the room dimensions and camera positions and orientation. As I mentioned, this implementation into VSTY, which is the short from virtual staging using artificial intelligence, has been supported by BOWI project, and I will talk about what kind of support we have received in later in this presentation. Okay, so obviously the question is why we develop this application and what can be used for. So there are a couple of problems today. Just a few numbers. The online sales for furniture worldwide, it's estimated in 2020 to $80 billion. However, there are reports saying that between 15 and 40% of what is bought online is actually returned. Another aspect that is interesting for this application is the home staging business, which means that many real estate owners or agents discover that it's much easier to sell a property, an apartment or a house, if you furnish it and then take pictures and market the apartment using those pictures. This is called home staging, and usually means that there are companies that brings furniture, put the furniture inside your house, take the pictures, and then take the furniture out, and that's it. It might take a few days, and it's according to what I've seen as a report, could cost $3,000, $4,000, $5,000 for one staging. So what this type offers? So basically, probably you have been in the situation to buy a sofa or a wardrobe, and then when you get it in house, you discover it's either too big or too small, or the color doesn't fit. You might think it's not like when you buy a shirt. When you buy a shirt, you go in the shop. The shop usually has a small booth, and you go inside, probe, test, take the shirt and see how it fits to you and so on. But this is not possible with furniture. So our product offers the customers the possibility to try the furniture in your room before actually buying it. So improve the customer satisfactions for all those companies that sell furnitures. Is not only actually a direct consequence of the customer satisfaction improvement is that the product will reduce the returned goods, which is not like returning a book or a shirt, is returning furniture, which means trucks and people to handle in and out from your house. Another interesting aspect is that we can provide home staging, but at much faster and lower cost. For instance, one image can be furnished by Vista in a couple of seconds, and the equivalent cost is could be in a range of dollars. And then maybe it's not that visible, but it also reduces pollution, because avoiding all those trucks moving furniture means like $20 billion worth of furniture, which is not actually moved. So it might mean a lot of pollution reduction. Okay, so a little bit about our history with BOWI. So I want to mention first that our company, Rofinntech 3D, is part of Transylvania IT Cluster, which is an organization here in Transylvania, which gathers quite a lot of IT companies. And then Transylvania IT Cluster is part of Transylvania Digital Innovation Hub, which it's a group of various clusters in different domains. Now, Rofin created this project with STI, and then we applied, being part of these organizations, to BOWI, to one of the BOWI calls, the one in 2019, and we were very happy to learn that we have been accepted in the project. So what that means, and actually what that meant and also means, because we are still running this project for Rofin. Here, I made a list which might look dry, but I want to talk a little bit about this. So of course, there's the financing. No company, especially the startups, could bring a product to the market without financing. So this is really good, especially for very early stage startups. Then BOWI project provides mentorship, both technical and business. I don't know how is it mentorship in other programs, but here for Rofin, it was really useful for various aspects. Especially because the mentors we have brought new angles to the problems and also sometimes solutions to the problems. It was very, very good collaboration we had with the mentors. Then something that is not actually written in the documents, but resulted is the fact that BOWI offered us a structured development of the project. So, you know, a startup usually is not lacking enthusiasm and ideas, and is so easy to derail from the main purpose of the whole project. So what BOWI brought us with this technology application roadmap is some kind of structure. It's not forcing, but it's helping us to keep the eyes on the ball, as you may say. So stay focused on what we actually want to develop. I want to mention, though, that this TAR, technology application roadmap, is actually not bureaucratic at all. I'm very happy because I've seen some other projects in my life. It's actually very clean, lean, and I'm very happy. So I really appreciate the way they developed this roadmap. Then, being part of this project, we were able, together with Transylvania IT Cluster and Digital Innovation Hub, to access a lot of extra resources. For instance, we were accepted into AWS Activate program, which provides us with a quite significant amount of services from AWS network. And also we have access to this PRACE, which is a network of supercomputers in Europe, so we can have access to these as well. These two things are actually very important for any company developing software, heavily intense, computing intense software like AI applications. Then, of course, networking and funding opportunities, there are quite a lot. I mentioned here just a couple of them. So thank you, Rainer, for bringing us to HighPeak and TETRAMAX. Well, I'm not in the TETRAMAX, but at least I'm aware what's happening there, and I can have access to a lot of other companies that are in similar domains. And also thank you, ESWEEK, for inviting us here. All in all, just drawing a line here, and I'm very honest on this, I highly recommend BOWI project for any early stage startup, because it brings exactly what a startup needs to bring a product closer to the market. Okay, that's pretty much all from my side, so I'm open to questions. Thank you all.
Perfect. Thank you, Mircea, and thank you to all the speakers for this session. I think we can probably stick around for another 5 to 10 minutes before they kick us out for the next event. Would anyone like to ask any questions before I have one or two maybe for Dimitry or Mircea in particular?
I actually have a question towards all of the 4 SMEs from TETRAMAX and from BOWI, but what next? So we heard that with some of you have started producing already a ready product. What are the next steps, and how can the ecosystem support you?
Well, actually, thank you for this question. I can speak about Vistai. So BOWI will bring this project ready to be launched, the beta version. So we are already having launched alpha, which means selected customers, but we will be launching it hopefully before the end of this year, the beta version, which will make the product available for general public. So next step will be obviously to make it commercial. So after all the feedback and the corrections from beta version, we plan sometimes in the spring to launch the product. Now, when it comes to what the ecosystem might provide for us, well, that's a very good question, because first, there are a few other financing opportunities that we are working with, the Digital Innovation Hub. Actually, I didn't know that BOWI has a further project. I don't know if this might be a continuation or not. I will check, whatever. And also we are in discussions with investors, because the main step after this will be to find a strong investor. We have been already in discussion with a couple of them, but in a way we are waiting for the right investor with the right amount of interest, not only money, but also support.
Thank you. That was a clear answer for me.
Oh, I wonder, Dimitry, maybe you would answer a question, a quick one. On slide 7, you showed that your artificial intelligence system, there was a curator at the end of it. I was a bit surprised that the diagram didn't show any feedback from the curator back into the artificial intelligence. I wonder if you would say something about that, if there's a way to take advantage of the human effort to improve the model that you're building.
Sure, I agree. This is called active learning, and this is actually the part of our technology. But this part is kind of embedded into the system already, so I wasn't highlighted very much. But of course, we have this mechanism. Then human annotator can highlight parts of the text and sends like a report to the system. So the system do additional training step, and after that provides better results. That, yes.
Okay, thank you for that. So I propose we'll have to give up the session, but if you're interested in trying to connect in the GatherTown, you can use the GatherTown locate feature to locate me, and I can be the anchor, if you like, for the next 10 or 15 minutes. I think in GatherTown you can have one-on-one chats with the video conferencing. I wonder, and otherwise I think Rainer and Kristina, we can close the session. I'm thanking everybody for their contributions.
Indeed. Thank you very much for all presenting the questions, and also for your team for organizing.
Yeah, same from the TETRAMAX side, and especially big thanks to Tim for setting all this up. Thank you.
It was a pleasure. I found the presentations all very interesting. So thanks to everybody, and please come into GatherTown if you like. Otherwise, I hope to see you all again in real life.
Okay. We will. No worries. Goodbye.
Bye-bye.
Okay. Bye-bye.
Thank you, Tim.
Bye.
Bye.